Hello everyone and welcome to this GibbsCAM Tech Tip. In this Tech Tip we're going to discuss intermediate tooling for GibbsCAM, what is intermediate tooling, and what are the benefits. Intermediate tooling typically is a block or a holder or some device that either mounts to a turret or to a spindle to hold the tool. In this case we have a turret and we have a OD turn tool. It could be a block for drilling. It could be a block that holds a boring bar. Or if you have the capability for milling, you can use milling holders. And this is what we would describe as intermediate tooling for lathe. Now, for a mill, we may have an extended holder like this for a face mill. Okay? So this would also be considered intermediate tooling. Or a right angle head for milling. What are the benefits of intermediate tooling? It gives you more accurate tool paths, including gouge checking, because you are telling GibbsCAM exactly what's on the machine. This also gives you better and more accurate simulation. The more you can see before your program hits the shop floor, the better. Okay, so what I'm going to do here is bring in an arbor. So we'll do a file, open, and here is our step file that we're going to use. We're going to open that, and it's going to read in the solid model. Now, the first thing we want to make sure of is that we're in line where the machine and the tool holder, or the arbor in this case, where it locks into the machine on the taper. So in this case, we're in good shape. Okay, we got lucky. Next thing I like to do is give this a name. So we'll just give it a name. Just so that we have it, can be whatever you like. I also like to give it some color. Okay, simple things. All right, the next thing we need to do is build a coordinate system where the tool is going to attach. So that's going to be on this face here. I'll turn on the face selection. I'll come over here to the coordinate system. I'll say a new CS. I'm going to call this tool position. And open up the CS palette, select the face, do an Alt align, and align a coordinate system to that face. Now I like to rotate it around so it matches the XY. So that's what I'm doing here. We just rotate it around so it matches the XY plane. Okay, so now we're ready to add this to our library. So we'll go up here to say File, Tool Block Library. We're going to put this in something called mill holders. We'll edit the library. And the first thing we need to do is add a child, and it's going to be a receptor. So basically, where the tool locates, right? And it could be anything. We like to say other, just because it makes it a bit more universal. At this point, we need to tell the software about the coordinate system. So I'm going to say from that coordinate system that we have, so it puts in all the correct values, sets all the vectors up properly. Then you don't have to do any of that. It's very nice. Then I'm going to add the body. So we're going to do a simulation body, and it's the arbor. Okay. So now we've added the arbor and the simulation body. Now, from here, we can either show this in a tool group. Right now, we don't have any tools. So what we're going to do here is go to my tools, and I'm going to load a face mill that I've created previously. We'll put that away real quick. And this is the tool we're going to use, and I'm going to show the block in the tool group. So you can see that it picks up the form tool. It's in the right location, and everything looks correct. We say add. Software is going to go out there and add this to our library. And now we have this tool in our library. Okay. Now what we can do is we can double check. We'll double click on the tool here. So this is our form tool that we previously created. It's a solid model. I can go up here to click here, and now I see the arbor. I can click it, adds it to the tool. As you can see, and we're now ready to use this tool and this holder. Arbor could be anything. Could be the right angle head. Could be a lot of different things. Okay, let's recap what we've done. We imported our file, making sure it's in the right location. Then we created a coordinate system where the tool is going to attach. That becomes our receptor point. Then we opened up our intermediate tooling library, selected the correct library. Then we went ahead and we added a node called receptor. Again, this is where the tool is going to attach. We selected that coordinate system and it fills in all the values. From there, we added the body as a simulation body, or the holder, of course, as a simulation body. Then we just said add, and it creates that and puts that in the library. At that point, we closed everything up, opened up the tool, and we were able to then apply that intermediate tool or that arbor, whatever you'd like to call it, to the tool. For more information about this or any other things GibbsCAM, please contact your local reseller. Thank you and have a great day.